Okay, Shehryar, please kindly proceed with your presentation.
Okay, sir. Bismillah ar-Rahman ar-Rahim. Um, Today the topic of presentation is ground improvement techniques. So these are my group members: Uzair Rahman, Nasir Wadud Babar, Muhammad Usman, me myself Shehryar Khalil, and Sayyid Farooq Shah. So the contents of our presentation are soil improvement, the purpose of the soil improvement, list of various types of soil improvement techniques, and technique for soil improvement. So first of all, what is ground improvement? So ground improvement is usually defined as using mechanical means to improve poor ground condition. That is to improve the soil properties to meet the project specification. As you can see here in this picture, uh, as you can see here in this picture, that the grouting is done where adhesive is injected under pressure to a pipe that improves the soil properties that by liquid form of material that decreases the permeability and improve the shear strength. Here this is a picture of the dynamic compaction. So what is the purpose of the improvement? What is the purpose of the ground improvement? So the first and the most important reason for the ground improvement is to increase the shear strength, to increase the durability of the structure soil, so that the structure may stand on the soil for longer duration, and to increase the stiffness and stability, so that the soil is stable and do not undergo any settlement during construction or after construction is completed. The next one is to improvement also modifies the soil permeability, where permeability is the rate of flow through different soil layers. So after the ground improvement is done, so the particle come close together, so the permeability of the soil is decreased. Similarly, mitigating undesirable properties. So we don't want the undesirable properties like shrinks, swell potential, or compressibility, liquefaction that usually causes cracks in our structures. These are the techniques that I will discuss in my presentation. That is micro piles for ground improvement. The next one is blasting, ground freezing technique for ground improvement, mechanically stabilized earth structure, ground freezing technique for ground improvement, and vibro replacement. So the first one is micro piles. So micro piles are small diameter piles up to 300 millimeter that has the capability of sustaining high loads over 5,000 kilonewton. The micropiles can be drilled into the ground in different conditions and at different angles other than the horizontal. Similarly, they can be adapted to operate in locations with low headroom and severely restricted access. These are used for the structural support and stability, for foundation of the new structure, repair and replacement of existing foundations, arresting and prevention of the movement. Similarly, embankment, slope and landslide stabilization, soil strengthening and protection. Here in this video, we can see how micropiling is done. So the drill and other is attached to the crane that is drilled down into the soil, and the casing is also attached to it to the different depth, where the drill is then removed from it, and reinforcing bar is inserted inside this. Then the trim tube is lowered down with the pressure to insert the grout into inside the casing, and casing is extracted 3 feet. And at the end, the pile cap is also placed at the top of the it. So this is how it is done. The next technique is ground freezing technique for ground improvement. So this type of technique uses ground freezing technique. So this is used the refrigeration to convert inside to pour water into ice. The ice that is formed will act as cement or glue that will bind together adjacent particles of the soil or block or rocks there to increase the combined strength to make them impervious. So whenever we have to do this technique is used to, we have to take into account certain consideration, that is thermal analysis, refrigeration system geometry, thermal properties of soil, rock, freezing rates, energy requirements, coolant, refrigerant distribution system analysis. The next one is mechanically stabilized earth structure. So these are segmental precast facing mechanically stabilized earth wall, employ metallic strip or bar mat or geosynthetic grid geotextile reinforcement that is connected to precast concrete. As here you can see in this picture also that the reinforcement is connected to this precast concrete slab. Similarly, how this is to be applied. So this is also a cost-effective alternative for the new construction, where the cost of embankment fulfillment, embankment fill, right-of-way, and other consideration may make steeper slope desirable. An engineered slope to improve compaction at the edges of the slope. The next technique is the blasting, where the densification of loose and cohesion-less ground is done. So there is a predetermined pattern that causes liquefaction, followed by the expulsion of a pore water. As you can see here, the expulsion of the pore water. This technique has been utilized for more than 80 years to densify loose saturated sand deposits. So this is the procedure. Different boreholes are drilled and the pipe is driven to the required depth. Then the detonator and the dynamic sticks are both enclosed in a waterproof bundle and is lowered to casings. Then casing is withdrawn and a weight of paper or wood is placed against the charge of explosive. Boreholes are backfilled with sand to obtain the full force of the blast. The charge is then fired in definite pattern. Here you can see in this video, first there is a blast and then you can see the expulsion of the pore water pressure. Then the next technique is the dynamic compaction. So in dynamic compaction, about 15 to 20 ton of weight is dropped from a height of about 10 to 15 meter, due to which the energy is transferred to greater depth. This technique is good to use for granular soil, large air wide soil, and organic soil. This is the animation. The 15 to 20 ton weight is raised above, and then it is dropped from a height. So this is how the compaction is done. The particles come close together and the compaction is done. This is dynamic compaction. The next one is the vibro replacement. So the vibro replacement uses a crane suspended downhole vibrator to construct the stone columns through weak soil, improving their load bearing capacity. The vibrator is usually about 4 meter long. You can see in this video. The stone column are used for compressive strength enhancement, and the dia of the stone column is usually 40 to 120 centimeter. As you can see, the probe is inserted in the ground until it reaches the required depth. Then the ballast is then incorporated into the ground, and the tool is raised from the base to the adjacent tube. The ballast is then also compacted through this tube. This goes inside and to the required depth. Here we can see as the probe moves upward, so the ballast is compacted also. This is how different stone columns are constructed. And now the building that will be safe on this soil, it will be safe and sound. Thank you.
Okay, thank you very much, Sheryar, and thank you for showing us those excellent videos and animations. Much appreciated. Okay, please kindly next
Thank
presenter
you.
share their screen.
Sir, screen visible?
Yes, it's visible and the voice is clear as well. Please
Thank
continue.
you, sir. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. My name is Ghulam Qadar, and today the topic of my presentation is ground improvement techniques. So my group members are Muhammad Anis, Muhammad Larasuf Khan, Arifullah, and Shujat Ali. What are the contents of my today's presentation? Objectives of the ground improvement techniques, and what are the techniques we use for the improvement of the ground. So what are the objectives of the ground improvement techniques? So the main objective of ground improvement techniques is to make soil be able to bear heavy loads without being failed and reduce the risk of settlements and slope failures. The soil improvement techniques are also being used to mitigate liquefaction hazards by avoiding the large increase in pore water pressure during the earthquakes by the densification of soils. So what are the uh, ground improvement techniques that we are using nowadays? So first of all, we are using a grouting techniques in which the adhesives are injected under the pressure through a pipe or borehole into the voids of the ground or in between the structure, and this process is called the grouting. Different adhesives like foams are being nowadays studies are being done on the foams to be used with the cement as a grouting material. So what are the applications of the grouting for different outcomes? So the grouting is used to control the groundwater during the construction and to avoid filling the and the grouting is used for filling voids to prevent excessive settlements and to strengthen the soils and to reduce the liquefaction effects. And another method that we nowadays using is the electro osmosis. It is the process in which we use a cathode and anode process to extract the water from the surface, from underground, from the depths of the soils. That is done when we excavate a hole. Sorry, 2 minutes. What is electroosmosis? It is the process that is used to increase the shear strength and the increased stability of soils, of soft clays and silts. In this method, the steel rods act as anodes that are inserted at the toe of the excavation, whereas the cathode are perforated pipes located away from the slope. Due to the applied electric field, ions are created and water molecules move toward the cathodes. However, this method is very expensive and rarely used. The another method that we nowadays using is prefabricated vertical drains. In this method, typically a surcharging load is used to expedite pre-construction soil consolidation. Surcharge will increase the pore water pressure initially, but with the time, water will drain away and soil voids will compress. Prefabricated vertical drains are used to shorten the travel time for the pore water that will reduce the preloading time. The another technique that you nowadays using is ground freezing. This technique is used in the construction of the shafts, mines, and tunnels to provide temporary earth support and groundwater controls when other conventional methods are not feasible. Ground freezing technique is done for almost all types of the soils that are near saturation are completely saturated. The concept is to convert pore water into the ice. Mainly liquid nitrogen is used with brine for the ground freezing. This That's all from my side. Now I would like to ask Arifullah to continue from here. Thank you.
Next slide. Sir, pre-compression by surcharge load. A site is preloaded by means of surcharge or by lowering the ground level, causing the ground to consolidate. After restoring original stress level, the future structure built on this site settle less than those on untreated ground. This technique is used for cohesive soils. Consolidation of these soils is a long-term process unless the existing longest drainage path is shortened by installation of short drains or geocomposite drains. Next slide. Another process is the vibroflotation. Vibroflotation, it is actually a ground improvement technique used at considerable depth that is used by using a powered electrically or hydraulically probe. It strengthens the soil, and this technique is used at considerable depth by using a powered electrically or hydraulically probes. It involves the introduction of granular soil to form the interlocking columns with surrounding soils. Due to water jet, the vibro floats is lowered and then granular material is dropped. Vibration is done to give the soil its desired unit weight. And vibroflotation utilizes water and the mechanical vibration of vibrofloats to move the particle into denser state, due to which the unit weight is increased. और सर वाइब्रो कंपेक्शन ये ग्राउंड इम्प्रूवमेंट है. It is a ground improvement technique that densifies, cleans, and cohesionless granular soils with a downhole vibrator. And the other is a field compaction. It is done through different types of rollers. It is least expensive and machines are easily available. And the different techniques to field compaction is a roller compaction, स्मूथ व्हील जो कि कंपेक्शन टाइप जो होता है स्टैटिक है, और कंटेक्ट प्रेशर जो होता है 380 kPa वो कंटेक्ट प्रेशर अप्लाई करता है, और कवरेज 100 यूज फॉर सबग्रेड ऑल साइल्स एक्सेप्ट रॉक्ड. और अदर टाइप्स ऑफ रोलर जो होता है ये न्यूमेटिक रबर है, ये स्टैटिक एंड काइंड नीडिंग and contact pressure 70 or coverage 80. It is used for dams, granulars, and fines. And also the rollers, the other rollers are sheet foot जो कि स्टैटिक और दुबुत के लिए इस्तेमाल होता है, और कंटेक्ट प्रेशर जो होता है 1400 to 7000, और कवरेज जो होता है 8 to 12, और क्लेली साइल के लिए इस्तेमाल होता है ये. एंड अनदर वन इज टेम्पिंग फुट जो कि बुत स्टैटिक एंड का नीडिंग के लिए इस्तेमाल होता है, और कंटेक्ट प्रेशर जो होता है ये 1400 to 8400, और कवरेज एरिया जो होता है ये 40, एंड यूज फॉर सिल्ट एंड क्ले. एंड अनदर रोलर टाइप इज मेश जो कि स्टैटिक एंड वाइब्रेटरी, और कंटेक्ट प्रेशर जो होता है 1400 एंड 6200, और कवरेज एरिया 50, यूज्ड फॉर रॉक, ग्रेवल्स एंड सैंड्स. गुलाम कादिर
जी
शुजात.
It is all from my side now. Shujat, it is Shujat Chabiq next.
Assalamu alaikum. Shujat Ali here. Now I will discuss the compaction technique last, that is dynamic compaction. Basically, dynamic compaction is a technique that densifies the soil and fills materials by using a drop weight. The ground is subjected to repeated surface damping using a heavy steel and concrete weight. Basically, 6 to 170 tons of weight is dropped, from the height of 20 to 100 feet. This technique is used for both question and non-questionless soils, and pattern is a triangular or rectangular pattern. And advantages of dynamic compactions are it is capable of compacting a wide variety of soils and enhance the bearing capacity, and also it is a sustainable technique. Thank you, sir.
Okay, thank you very much. Who is the next presenter, please?
Yes, sir.
सर हम कर रहे हैं प्रिंट
सर हमने शेयर किया हुआ है स्क्रीन
Okay, let me check the comments there. No comments there. Okay. Svandyar, you need to share your screen once again. Yeah, that's good. So we are starting at 3:40 p.m. Maximum 10 minutes allowed. Please continue.
अस्सलाम वालेकुम am I audible sir
Yes.
यस हम
Assalamu alaikum, this is Hamid Ibtihaj Peer and following are my other group members that include Uzair Khan, Asfanjar and Janita Manur Shahid. The topic of our presentation is ground improvement techniques in geotechnical engineering. Next slide please. Following are the contents of our presentation that includes ground improvement desired in soil, and techniques for ground improvement that include deep dynamic compaction, deep soil mixing, stone columns, vibrocompaction, vibroflotation, jet grouting, and blasting. Next slide, please. Ground improvement. Ground improvement is the procedure typically defined as using mechanical means to improve poor ground conditions. Ground improvement methods improve the engineering properties of the soil mass, which is treated to meet project performance requirement. Used if it is used correctly, ground improvement can be used to engineer complex sites, simplify follow-on construction, and minimize development costs. What is ground improvement? Basically, ground improvement is very important. If we want to start a project on a certain site, we must see that we must first of all evaluate our soil on which we want to start our project. So we want to check if the soil is adequate or not for a project, because there are certain requirements of our project that definitely there be some load that will be applied on the soil. So will it bear it or not? So we have to evaluate our soil to check certain engineering characteristics of the soil. So ground improvement is the application of geotechnical techniques to improve the soil engineering characteristics. So we apply certain ground improvement techniques to enhance the characteristics of the soil. So improvement desired in soil. So basically we want to why what was the purpose of the ground improvement technique? So basically we need to improve the bearing capacity of the soil, densify the soil, reduce settlement of the soil, avoid permeability of water into the soil, mitigate liquefaction, and increase slope stability. As we know that bearing capacity is a very important phenomenon of soil. We want to resist the load that is being applied on the ground. That is done with the help of bearing capacity. Basically, bearing capacity is the capacity of the resistance of the soil to resistance of the soil against the load applied on the ground. So techniques that we use for improving the bearing capacity includes compaction and grouting, grouting materials that are injected into the soil to enhance the bearing capacity of the soil. Another one is densification of the soil. So basically densification is a process in which we rearrange the soil particles to a tighter arrangement to resist shear stress. That can be done with the help of compaction. Settlement control. If we have a loose soil with looser resistance towards the loading, our soil settles, as a result of which our building may fail, or building will settle and our project will fail. So in order to avoid that, we compact our soil. to reduce the compressibility of the soil, permeability of water. As soil, we want to avoid the permeability of water into the soil, so we can avoid that with the help of grouting or hydrating lime mixing with the soil. Another one is the liquefaction. Liquefaction is a process basically when we have a saturated or partially saturated soil, it loses strength and stiffness due to loading. And it starts to act like a liquid under certain loading, like earthquake loading. So in order to avoid that, we provide proper drainage to handle liquefaction. So we have another one was increasing the slope stability as well as purpose of improvement. Techniques for ground improvement. We have a wide range of techniques to improve the ground, but we will discuss.
Amit, excuse me.
GG, sir.
If you are having a severe throat infection, I'm okay with that if you want to stop.
No, sir, it's fine. I'll continue. But this is the
Okay.
last slide for me.
Okay.
Techniques for ground improvement. There are a wide range of techniques for ground improvement, but we will discuss the following techniques. That includes deep dynamic soil compaction, deep soil mixing, stone column, vibrocompaction, vibroflotation, jet grouting, and blasting. Now that's it from my side. And now Asfanja will continue the presentation. Thank you.
Thank you, Hamid. Assalamu alaikum, everyone. I'm Asfandia, and Hamid mentioned we'll be presenting the first. I'll be presenting the first three, and our group member Janita Manur will present the last three. Starting with the first technique used for ground improvement, the deep dynamic compaction. In this method, a crane is used to drop heavy weights ranging from 10 to 170 tons from a varying height onto the ground. The height may be up to 85 feet. So because of this, we can also call it heavy tamping. It can be used for silty, fully and partially saturated sands. It is done in a grid pattern in which the distances between the grid points may range from 6 to 40 feet. The maximum depth up to which improvement occurs is 100 feet. And in that 100 feet, the effective depth is up to in the range of 30 to 35 feet. The improvement occurs in the following properties. Number one is that the densification is increased, the soil is densified by up to 80%. The SPT blow count is increased by 25, and the CPT cone resistance is increased by 1400 to 2200 psi. This technique is easy to perform and widely available, and also no dewatering of soil is needed in this technique. The effective depth, as I mentioned, is up to 35 feet, so the improvement below that is significantly low, and it should be, and also it should be done with proper care because the ground vibrations could have an impact on the adjacent properties. Here's a video illustration showing the deep dynamic compaction. As you can see in the video that a heavy weight is lifted up to a certain height and dropped onto the ground. It causes the soil to compact, and hence the properties of the soil are improved. Next is the deep soil mixing method. In this method, a drill rig with either one or multiple augers is used to drill into the ground and simultaneously mix additives like grout, lime, or fly ash with soil to increase its strength. It can be used for all types of soils. The application pattern varies. That is, sometimes it is done in a grid pattern, sometimes circular. Also, the maximum improvement depth usually depends on the equipment's reach, which is usually between 80 to 100 feet. It significantly increases the strength of soil, but the disadvantage of this method is that special equipment and highly trained professionals are needed to perform this procedure, which are costly to hire, and hence the cost is also very high for these procedures. A visual representation of deep soil mixing is shown in this slide. First, the soil is drilled into, and then additives are mixed with the soil, and it is taken up to the top. The next one is the stone column method, in which compacted stones are poured into pre-bored holes within the soil, creating a column that improves the soil properties. It is used for soft clay soils in grid pattern. Also, the stone column increases the bearing capacity, reduces the total settlement, and also lowers the risk of liquefaction. The video in this slide shows the horizontal and vertical vibrations of the machine compacting stones. These are the horizontal and vertical vibrations, creating a column-like structure which we know as the stone column. These are how the stone columns are constructed. This is all from my side. Now, Ms. Anita Manu will present further.
From here on, I will carry out this presentation. So let's begin with vibrocompaction and vibroflotation. It is a technique which densifies the granular soil by insertion of heavy vibrating probes up to a desired depth, usually 150 feet or maybe beyond that. This probe is also called a depth vibrator or vibrofloat. This vibrofloat imparts horizontal vibrations of 30 to 50 hertz frequency into the ground and break down the frictional contact between the soil particles and reduces its effective stress, resulting in a dense soil structure. The application is done in a grid pattern with 5 to 10 feet spacing between each probe insertion point. Coming up next is the visual representation of this method. Here we can see how the granular soil is being dumped onto the insertion point and the soil is densified with vibrations. Next is jet grouting. This is the method of ground reinforcement in which high kinetic energy in the form of high velocity jet of grout is used to break down the soil structure and simultaneously mix the cement grout with the in situ soil. There are several types of jet grouting which will be explained in a video. Please change the slide, Asfandar. This is cement grouting, in which a cemented mass is created in order to strengthen the soil. Next is the chemical grouting. This is fracture grouting, in which the structure is lifted with the help of creating cemented mass called lenses. This is polyurethane grouting. This is the single fluid system. This is the third triple fluid system. The last method is of blasting. Blasting is the method in which the buried explosives are used to densify the loose cohesionless soil. A series of boreholes are drilled with pipes of diameter 7.5 to 10 centimeter, in which dynamite sticks are fixed, and then they are backfilled with the boreholes are backfilled with soil to obtain full force of the blast. The charge is fired in a definite pattern. The energy released by explosions create a compressive radial stresses in the soil, which are generated as the shock waves approaches towards the source, and then the tensile stresses are produced as they pass. The resulting cyclic stress increases the pore pressure, and effective stresses are gradually reduced. As pore water pressure dissipates, the grains of the soil rearrange themselves into denser and more stable configuration. With this, we have reached to the end of this presentation. It will be ended with the visuals. This is the dynamite being placed. This is the grid pattern in which dynamites are arranged. Thank you for your time and attention. Questions are
Okay,
welcomed.
thank you very much, and thank you for showing us all those videos and animations. It helped us a lot in understanding those processes. Thank you. Who's next? I guess someone requested for. Let me check. Mohammed Riaz. Yeah, after Mohammed Riaz, Mashal will present.
Yes, sir.
Mohammed Riaz. Okay, yeah, you are there in the members. And after this presentation, Mashal will present. Please, okay, we are starting at 3:53 p.m. 10 minutes maximum, please.
Bismillahirrahmanirrahim. My name is Muhammad Riaz, and my group members are Lal Zaman, Sajad Khan, Shazim Muhammad, and Inayatullah. The the topic of my presentation is ground improvement, uh, and I am presenting this to Dr. Muhammad Sabdar. First, I will define ground improvement. Ground improvement is the procedure typically defined as using mechanical means to improve foreground conditions. Ground improvement methods improve the engineering properties of the soil mass, which is treated to meet project performance requirements. The common reasons for ground improvements are the following: improve bearing capacity, increase density, control settlements and permeability, mitigate liquefaction, increase slope stability. Uh, the latest ground improvement techniques. The following are the latest ground improvement techniques. Number first, vibrocompaction, vacuum consolidation, preloading of soil, vibro replacement stone columns, ground freezing, soil stabilization by heating or vitrification, mechanically stabilized structure, soil nailing, micropile, and the last one is grouting. The first one, vibro compaction or vibroflotation. It is the rearrangement of cell particles into a denser configuration by the use of powerful depth vibration. Vibrocompaction is a ground improvement process for the अभी वॉइस ठीक है
Yes, it's clear. Please continue.
ठीक है thank you. The vibrocompaction is performed with specially designed vibrating probes. The probe is first inserted into the ground by both jetting and vibration. After the probe reaches the required depth of compaction, granular material, usually sand, is added from the ground surface to fill the void space created by the vibrator. A compacted radial zone of granular material is created. Advantages of this method. The following are the advantages of this method: reduction of foundation settlement, reduction of risk of liquefaction due to seismic activity, permanent construction on granular fells. Sajad, you play the video. In this, you can see the method of VIBROCOMPACTION. The second method is vacuum consolidation. Vacuum consolidation is an effective means for improvement of saturated soil. Mm, saturated soil. The soil site is covered within uh, air airtight membrane, and vacuum is created underneath it by using dual venture and vacuum pump. The technology can provide an equivalent preloading of about 4 or 5 meter high conventional surcharge fill. Vacuum assisted consolidation preloads the soil by reducing the pore pressure while maintaining a constant total stress. Application of vacuum consolidation uh, replace standard preloading techniques, eliminating the risk of failure. Combined with the water preloading in scarce fill area, the method is used to build large developments on thick compressible soil. Combined with embankment preload using the increased stability. Uh, in this video, you can see the method. Uh, for the remaining part of the presentation, I am inviting my another group member, Sajad Khan. Please present the remaining.
Hello, is my voice audible?
Sajad, please kindly share your screen once again. Yeah, it's good now.
Bismillahirrahmanirrahim. My name is Sajad Khan. From this on, I will continue the presentation. The third method is preloading or pre-compression. Preloading or pre-compression is the process of placing additional vertical stresses on a compressible soil to remove pore water over time. The pore water dissipation reduces the total volume, causing settlement. Surcharging is an economical method for ground improvement. However, the consolidation of the soil is time-dependent, delaying the construction project, making it a non-feasible alternative. The soil treated or organic soil in this method, wort silt and clays, soft clays, dredge material. The design consideration in this method which should be made are bearing capacity, slope stability, and degrab consolidation. Where this method is applicable, so it reduces the post-construction, reduce the settlement, reduce secondary compression, it increased densification and improve the bearing capacity. The fourth method is the vibro replacement stone column. The vibro replacement extend the range of soil that can be improved by vibratory technique to include the cohesive soil. Reinforcement of the soil with compacted granular column or stone column is accomplished by the top feed method. The importance of Weber replacement stone columns are ground condition, relative density, degrab saturation, and permeability. Application for this method are The reduction of foundation settlement, improve bearing capacity, reduce putting size requirement, reduction of the risk of liquefaction due to seismic activity, slope stabilization. It permits construction on fill, also permits shallow foundation construction. This is animation for this method. Next fifth method is the ground freezing. Ground freezing is the use of refrigeration to convert the N2 water to ice. The ice then acts as a cement or glue, bonding together adjacent particles of soil or block of rock to increase their combined strength and make them impervious. The ground freezing consolidation or thermal analysis refrigeration system geometry, thermal properties of soil and rock, freezing rate, energy requirement, coolant refrigerant distribution system analysis. Application of ground freezing technique are temporary underpinning, temporary support for an excavation, prevention of groundwater flow into excavated area, temporary slope stabilization. Sixth method is the soil stabilization by heating or vitrification. Heating or vitrification breaks soil particle in order to form a crystalline or glass product. It uses electrical current to heat the soil and modify the physical character of the soil. Heating soil permanently alter the properties of the soil depending on the soil temperature can range between 300 to 1000 degrees Celsius. The impact on adjacent structure and utilities should be considered when heating is used. Seventh method is mechanically stabilized earth structure. A segmental precast facing mechanically stabilized earth wall employs metallic strip or bar mat or geosynthetic, geograde or geotextile reinforcement that is connected to a precast concrete or prefabricated metal facing panel to create a reinforced soil mass. Next one is soil nailing. The fundamental concept of soil nailing consists of reinforcing the ground by passive inclusion closely spaced to create inset to soil and restrain its displacement. The basic design consists of transferring the resisting tensile force generated in the inclusion into ground through the friction mobilized at the interface. In this animation, they first create a borehole. After that, they insert the bar and nail it. And then spring, shotcrete or any other. Next one is micropile. Micropiles are small diameter pile up to 300 mm with the capability of sustaining high loads, compressive load of over 5000 kN. The drilling equipment and method allows the micropile to be drilled through virtually every ground condition, natural and artificial, with a minimal vibration, disturbances and noise at any angle below horizontal. The equipment can be further adapted to operate in location with low headroom and severely restricted access. So they insert here micropiles. First insert a casing. After maximum depth, the rod is removed and reinforcing bar is placed inside. Case is extracted after every 5 feet of grout. And at the end, final cape is installed. The last method is grouting. For grouting, falling strips are involved. Identify unground construction problem, establish objective of grouting program, perform special geotechnical study, develop initial grouting program, develop performance prediction, and compare with other solution. Refine design and prepare specification. Grouting techniques, the various injection grouting technique used by the grouting contractor for ground improvement, ground modification can be summarized as follows: permeation, compaction grouting, flagage, and jet grouting. This is animation for grouting. This is the case of cement grouting, in which they inject cement grouting into deep to stabilize the ground soil condition. This is jet grouting. Thank you for your patience.
Okay, thank you very much, Sajad. Thank you very much, Riaz and other group members for presenting those excellent animations and videos. Guess the next is Mashal. Please kindly share your screen. You are
Okay,
starting at
Bismillahir
4:10
Rahmanir
p.m.
Rahim. Assalamu alaikum.
Please kindly finish it in 10 minutes.
Okay,
Wa alaikum assalam.
Inshallah. Okay, this is Michelle Shahjahan, calling the remaining class member of my group members. So today the topic that I'm going to present is exam improvement technique. Here comes the content of my presentation. Okay, I'll leave it here. Introduction to the ground improvements, why we need ground improvements, and the ground improvement techniques. So basically, ground improvement is a procedure typically defined as using mechanical means to improve the poor ground conditions. Ground improvement methods improve the engineering properties of soil mass, which is treated to meet project performance requirements. Then there came the question that why do we need ground improvement? So it is needed in order to increase the shear strength, to reduce the permeability, to reduce compressibility, to improve the bearing capacity of the soil, to increase the density, to improve settlement and permeability, mitigate liquefaction, and to increase the soil stability. Here we got some methods for the ground improvement. I'll be explaining them with the help of text and some animations. So that are the pre-compression or the pre-loading, the explosion, the heavy tamping or dynamic compaction, the vibro replacement, the compaction grouting, vibrocompaction, penetration of pressure grouting, soil replacement or chemical treatment, jet grouting, soil stabilization by heating or liquefaction, and the soil kneading. So the first one is the pre-compression. What happens in this method is that a site is preloaded by means of surcharge or by lowering the groundwater level, which causes the ground to consolidate. After restoring the original stress level, like in future when structures will be built on this site will settle less than those on the untreated ground. It's preferably used for the cohesive soils. And then there is the blasting. Rather than reading the text, I'll be explaining this with the help of this animation. Okay, so basically this process involves the detonation of explosive charges at certain depth below the ground level in saturated soil. We have 3 to 5 successful detonations are usually necessary to achieve the desired compaction. And like soil up to the depth of about 18 meters can easily be compacted with this method. Then there came a heavy damping or dynamic compaction. So in this method, like this is used to increase the density of soil like all other ground improvement techniques. When certain subsurface constraints make others not inappropriate. Also, I'll be explaining its procedure with the with the animation. So basically, this process involves the dropping of heavy weight repeatedly on the ground at regularly spaced intervals. The weight and the height determine the amount of compaction that will occur. And the weight that is used mostly depends on the degree of compaction required, and it's usually between 8 to 36 tons. Then there's the vibro replacement. Going to its visual. This is the method of constructing densely compacted stone columns using a depth vibrator to densify the aggregate backfill in surrounding granular soils. And the stone columns basically reinforce the soil. It can be seen that how the stone column is inserted and how it's being done in the field. It's suitable for weak and cohesive soils. Then there is the other method, that is the compaction grouting. So what we do in this method is that we inject some stiffer grout into the ground at specified depth using medium to high pressure. I'll be explaining its procedure with the help of this visual. See, that's how the grout is injected, and this grout injection process creates and expands grout cavity near the bottom of the column, which presses against the surrounding soil and increasing its density. Okay, the next one is the vibrocompaction or the vibroflotation. So again, explaining it with the help of a visual. Okay, so this method of ground improvement has large crane, which can be seen in this video, which lower the vibrating tubes into the ground. See the probes vibrate in cyclic action in order to cause the granular soils to rearrange themselves in a more denser configuration. See the cyclic motion. But one thing shall be kept in mind is it's not suitable for clays and silts. But its advantage is that it's like easier to achieve the uniform and densified soil with this method. And the other is that vibrations felt to the ground are generally less than those caused by deep dynamic compaction and blasting. Then we have the penetration or the pressure grouting. So in this method of ground improvement technique, we use a fluid cementitious grout and we pump it into the ground at high pressure. So the high pressure basically forces the ground to fill in the void and void spaces in granular material, which results in the higher density, resulting in the improved strength, stiffness, and lower hydraulic conductivity. This grouting method requires boring several holes spaced 3 to 10 feet apart across the site. In this figure, it can be seen that initially drilling is done, then high pressure grouting, then execution of the jet grout column, and then repeating for the next column. The other method is the soil replacement with the chemical treatment. So in this technique is used to remove the poor quality of soil and replace it with a good or engineering soil. The advantage is that it doesn't require specialized equipment, but we also got some disadvantages that like excavation requires money, a lot of money, and it's highly economical, non-viable, and also it takes some more time. And in the areas where we have high water tables, so first we will have to dewater the site before this method is being done in the site. They are mostly done at the depths of less than 10 feet. Then there came the jet grouting. I'll be explaining this with the visuals since I got it here. Okay, so in jet grouting, what we do is that a special drilling rig, which can be seen with the nozzle, is used to drill a hole into the earth to a specified depth. And this nozzle ejects water or air or both, the combination of water and air, at a depth, and it creates a cavity that can be filled with the grout. This grouting technique creates soil cement columns of any height with diameters ranging from like 2 to 3 feet wide or to 16 feet depending on the soil type and jet grouting equipment being used. And next is the soil nailing. The soil nailing technique, I'll be explaining it with this one. So soil nailing is basically a technique which is used to reinforce the soil to make it more stable. Apart from that, it is used for like slope excavation and retaining walls, etc. In this method, as it can be seen in the visual, that soil is reinforced with slender elements such as reinforcing bars, which are called nails. And these reinforcing bars are installed into the pre-drilled hole and then grouted. And it can be seen in the visual that they are installed at 10 to 20 degrees with the vertical. Okay, that's all from my side. At this time, I would like to hear from you with your thoughts or questions. If there are any, thank you so much for listening very carefully.
Okay, thank you very much for finishing it within the duration which was set for the presentation. And I particularly like the way you focus more on the animations and the interesting aspect of the presentation. Thank you so much. Please, Osama, share your screen. Sama. Please kindly share once again. We are starting at 4:20 p.m. Please kindly finish
Yes.
your presentation within 10 minutes. Thank you.
सर वकार हकीम शुरू करेंगे.
Click on hide.
Yes, sir.
Yes, please proceed.
Bismillah ar-Rahman ar-Rahim. I am Waqar. And these are my group members, Ibrarul Haq, Muhammad Usama, Abdullah Riyaz, and Ishamuddin. Contents of the presentation is various ground improvement techniques used in geotechnical engineering. So starting with the introduction, so soil improvement is the alteration of any property of a soil to improve its engineering performance, which may either be a temporary process or a permanent. And this can be done by reducing the pore water pressure of the soil, and pore water pressure can be reduced by reducing the volume of ions in the soil or by adding some stronger materials into the soil like cements or any other additive. And the results of application of a technique may be to reduce to increase the shear strength of the cells, compressibility, reduce the compressibility of the cells, and increase the bearing capacity of the cell, and reduce the permeability of the cells. Next. So need of the ground improvement technique. So the need of the ground, currently we see that the most of the problem of the urbanization. So the rapid urbanization and industrial growth divide land demand for land. In order to meet this demand, land reclamation and utilizations of unsuitable or environmentally affected lands we will take up, where poor ground condition may make traditional forms of construction expensive. It may be economically viable to attempt to improve the engineering properties of ground before building on it to improve load bearing capacity and shear strength. Next. So ground improvement techniques. Number first is the mechanical compactions. So in mechanical compactions, we use different machinery like rollers, and at this type of compaction we perform for shallow siles like for roads, and uh, if, in the event of weak cells being present up to certain depth, so the same is replaced with the near up good cells. This can also be done for improvement of the cell by mechanical mean. And also we can use the sheep wood rollers and vibrator rollers are used for cohesive and cohesionless cell respectively. Next, cell stabilizations. So cell stabilization we can do by three types: mechanical, chemical, and cementing. So by mechanicals methods, we change the proportion of the cells by mixing the sand and gravelly materials. And by chemical means, we apply some certain chemicals like lime, calcium, and sodium chlorides at mixtures and waterproofers, aggregates, etc. And cementing. In the cementing method, we use different binders like cement, lime, fly ash, or bituminous materials. Next, preloading. We use this techniques for sanitary landfills. It is in engineering landfills. We apply preloads for cells to improve the bearing capacity of the cells. And we can see in the figures that surcharge load is applied on the cell, uh, and the settlements in the time curves. We can see that one Q2 is greater than Q1. So Q2 curve. So Q2 curve settlement is more than Q1 time curves. So this is from my side. From here onward, Usama will continue. Ibrar will continue.
Thank you, Akar. Please confirm that my voice is clear.
It's clear.
Yes.
So let's suppose we have an engineering project that we have to construct at a particular site, but unfortunately we have loose soil whose bearing capacity, whose shear strength and stiffness is low. So among different methods, one of the method is to insert stone columns. What we will do in this method, we have to dig a hole with the help of machineries, and then to put stones from 6 to 40 mm from 6 to 40 mm diameter in that hole, because we know that the compressive strength and the bearing capacity of the stones are greater than that of the soils. And the distance between the columns of stones depend upon the type of project, and but usually it is from 1 to 3 meters. Next, please. And the fifth one is compaction piles. So it is similar to that of the stone columns, but stone column is a particular type, and this is a common type. In this method, we have to insert columns. Columns are piles of different materials which are stronger than that of the loose soils, maybe that of made of sands, etc. This method is same. The procedure is same as that of the previous method. We have to dig a hole, and then we have to insert the sand, etc. But one of the method is to insert a metal plate, to insert a metal plate with fitted with collapsible door. Sand is filled in the hollow steel pile, and then pipe is slightly lifted due to load. The bottom flat open out, and the sand backfills the voids created during drying of the pipe. And the refilled sand prevent the surrounding soil from the collapsing. Next, please. And this method particularly, we will use this method when the foundation is below, means when the foundation is below the groundwater table, or when the site is located in such an area that where direct access is not restricted, when the design foundation is restricted by number of boundaries in contact zone, and when excavation is not possible besides the proposed structures. So mainly we will use this method when the direct access to the ground is not acceptable, because we will next we will see in the pictures that laterally we do this method, and without affecting the particular area we can go through this method. Next, please. So here in the picture, you can see that literally we create holes and that we do the grouting. So for the next important part of the presentation, I will invite Muhammad Usama to present.
Bismillahirrahmanirrahim. Rabbi zidni ilma amin. Thank you, Abraham Haq, for inviting me. The next one, sir, मेरा आवाज clear है?
Yes, clear.
Yes, clear.
The next ground improvement technique which is included in this particular presentation is the soil reinforcement. So basically the soil reinforcement technique is actually installing reinforcement bars in the soil. They may be steps, they may be bars, they may be any other anchors, planks, etc. So it is the combination of the earth fill and the reinforcing steps. Its objective is to increase the bearing capacity of the soil and the tensile strength capacity of the soil. It is particularly used where the soil is very soft and it is incapable of taking the superstructure load. A wide range of the materials such as the steel, glass, concrete, fibers, wood, aluminum, etc. can be used as a reinforcing agent for the reinforcement of the soil. These reinforcement can be in the form of the steps, anchors, planks, as I told earlier. Here in the picture, we can see that whenever these reinforcing bars are installed in the soil, the stress which is applied by the superstructure on the soil is shared with the reinforcing bar, and the combined strength of the soil is increased. The next one is the Vibrocompaction or the Vibroflotation. So it is the rearrangement of the soil particle into a denser configuration by the use of a long depth vibrator. A vibrating probe is inserted in the soil. It creates waves inside the earth. So the waves generate the waves when these are generated, they compact the soil, and thus the soil is compacted into a stable configuration. The combined action of the vibration and the water saturation by jetting rearrange the loose sand grains into more stable and compacted state. So the water is also injected with the vibrator, because when the water is injected in the earth, it helps the soils to rearrange its position, and thus the soil is rearranged in the stable configuration. The benefits of the vibrocompaction are reduce the foundation settlement, because whenever the vibrocompaction is done, the pre-construction settlement in the soil occurs. So when the building is constructed on that soil, further settlement will not occur. It also reduces the risk of liquefaction due to the seismic activities, permit construction of the on granular pills, because the granular pills have large voids, and due to this vibrocompaction, the voids are reduced. The next one is the soil nailing. So we have told about the soil reinforcement, and this is a type of the soil reinforcement. In this method, the nails, some bars, reinforcing bars are installed in the soil, which are known as the nails. These reinforcing bars are installed into the pre-drilled hole and then grouted. The nails are installed at about 10 to 20 degree with the vertical, or maybe larger degree with the vertical. In the video, it is at a larger degree. There are various methods for installing the soil nailing in the soil. The methods are the name of the methods are given here. It is mainly used for the stabilization and reinforcement of the soil. Here in the video, a hole is drilled in the soil, and then it is filled with the grout. Then a steel probe is inserted in the soil. Now it is tightened by a plate. The shotcreting is done in the last. Unfortunately, or maybe fortunately, soil are made by nature and not by men. and the products of nature are always complex. Karel von Tirzavi.
Thank you so much.
Thank you, sir.
I want to read it again. Usama, excellent sentence which was said by Carl von Terzaghi. Please kindly repeat it again.
Unfortunately, soils are made by nature and not by man, and the product of nature are always complex.
Yeah. After a very long time, I'm reading it when I was at Western University in Canada. So one of my friend brought me this sentence, and he read that in front of me, and we were investigating the static properties and dynamic properties of the soil, and he came up with this sentence. So excellent sentence. Thank you so much.
Yes.
Excellent and nice presentation. Okay, who is next?
Thank you, sir.
Assalamu alaikum, sir.
Wa alaikum salam. Arif Nawaz Khan.
Shahsawar, kindly share the slide.
Okay, please try to finish your presentation within 10 minutes. Thank you.
Okay, sir. It's too short. Shahsawar. Sir, am I audible?
Yes, please continue.
Okay.
Time
Okay, sir.
4:34.
Okay, sir. Bismillah ar-Rahman ar-Rahim. The topic of the presentation is about the ground improvement techniques used in the geotechnical engineering. These are our group members. Ground improvement. Various techniques are available for the ground improvement, each with advantages and disadvantages. The selection of the appropriate technique is based on the site-specific condition and the project needs. The method can be distinguished in a several ways by techniques that can be applied from the ground surface, those that are carried out from a certain depth below the ground surface, the nature of the material that can be treated, such as a cohesive and a granular material, the behavior of the ground needing improvement, and the use of different type of.
Next slide, Arif. Next slide, please.
The objective of the ground improvement is to improve the bearing capacity of soil, to increase the density, control settlement and permeability, mitigate liquefaction, increase the soil slope stability. The various ground improvement techniques are following, including vibro-compaction, vacuum consolidation, pre-loading of soil, soil stabilization by heating and vitrification, ground freezing, vibro replacement, stone column, mechanical stabilization of earth structures, soil netting, micropile, and grouting. Vibrocompaction is a ground improvement technique that densify clean and cohesiveless granular soil with a downhole vibrator. The common use are to reduce the foundation settlement, increase the bearing capacity, allowing reduction in foundation size width, increasing the stiffness, similarly increasing the shear strength, reducing the permeability, mitigate potential for liquefaction, provide increased slope stability, permit shallow footing construction, very effective for sand compaction and land reclamation. The process is a vibratory.
Next
Okay,
slide, please. Yes.
this is a pictorial view, sir. Actually, I'm from presenting from mobile, so it's just a picture. It's a North plane. And the next one is the vacuum consolidation. Vacuum consolidation is an effective means for improvement of a saturated soft soil. The soil is covered with an airtight membrane, and a vacuum is created underneath it by using a dual venture and vacuum pump. The technology can provide an equivalent preloading of about 4.5 meter high conventional surcharge fill vacuum assisted consolidation preload the soil by reducing the pore pressure while maintaining a constant total stress. The application of the vacuum consolidation for a soil replaced standard preloading techniques, eliminating the risk of failure combined with the water preloading in a scarce fill area. The method is used to build a large development on the thick compressible soil combined with the embankment preload using the increased stability. This is the pictorial view. The third one is the preloading of soil. Preloading of soil has been used for many years without change in a method or application to improve the soil property. The preloading or pre-compression is a process of placing additional vertical stresses on a compressible soil to remove pore water or time. The pore water dissipation reduces the total volume causing settlement. Application of the preloading of soil reduce post-construction settlement, reduce the secondary compression, densification, improve bearing capacity. This is the pictorial view. On the left side, we can definitely see where the preloading is done, and the footing is spread footing, which actually decreases the cost of construction. And on the upper side, we can definitely see the pile, which is costly, how the preloading reduce the cost of construction. The third one is a mechanically stabilized earth structure. A segmental precast facing mechanically stabilized earth wall employ metallic strip or a bar mat or use synthetic geograde or ductile reinforcement that is connected to a precast concrete or prefabricated metal facing panel to create reinforcing soil mass. The application of mechanically stabilized earth structures or the reinforced soil structures are cost-effective alternative for new construction where the cost of embankment fill, right-of-way, and other consideration may take a steeper slope desirable. Another use of the reinforcement in an engineered slope is to improve the compaction at the edge of a slope to decrease the tendency for surface sloughing. This is the pictorial how the mechanically stabilization of the soil has been done. It's all from me. Thank you, sir.
Thank you so much for your participation and presenting. Who's
Oh,
next,
welcome.
please?
Sir, all slides have been presented by me, sir.
Okay.
I'm seeing.
Thank you very much.
Thank you so much, sir. Sir, we should post this